Algebra 2. Today we're going to start the last unit on radicals, and it's section 6.1 in your textbook. Roots is another word for radical, roots and radical expressions. On the first screen you see a list of perfect squares and perfect cubes. We have worked with the perfect squares before. I stopped at 10 squared, but this list actually, both lists, keep going forever. So I want you to kind of keep that in mind. I would like you to write down the entire screen in your notes. This is going to be your reference. You're going to have to continue to look at these numbers in order to do the problems in this entire unit. When you're looking at a square root problem, you want to look at perfect squares. Perfect squares are numbers that are raised to the second power. 1 to the second is 1. 2 to the second, or 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16, so forth. Numbers like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and so on. These are numbers that are perfect squares. These are the numbers, again, that you are going to be looking at when you're trying to do square root problems, like that. Perfect cubes are numbers that are raised to the third power. 1 to the third is 1, 2 to the third 8, 3 to the third 27, 4 to the third 64, 5 times 5 times 5 is 125, 216, 343, 512, 729, 1000, and the list continues. If you'll just kind of base your problems off these numbers, most problems will be dealing with just these numbers, but if there's anything higher than these values in your problem, you're going to need to use your calculator. You're going to look at perfect cubes list when you see a cube root, and you'll see a little tiny 3 and then the radical symbol. So any problem that contains this math symbol, you're going to want to focus on this set of numbers instead of this set. Square roots and perfect squares are opposites of each other. Perfect cubes and cube roots are opposites of each other. Again, very important that you write both lists in your notes and that you study these, that you know them. The faster you memorize these and learn these, the easier this unit's going to be. Squaring a number, raising a number to the second power, and then taking the square root of that are inverses of each other. And again, that means that they're opposites. Squaring a number and then taking the square root are inverses. Cubing a number, raising it to the third power, and then taking the cube root are inverses of each other. So, quick sample, if I gave you the number 7 and asked you to square it, raise it to the second power, that's the same thing as saying 7 times 7. Well, that answer is 49, of course. Then if I took my answer, 49, and put it underneath the square root symbol and wrote it like this and asked you to give me the value or the simplified answer to this math symbol means what number times itself is 49? And the answer to that is 7. So notice that the number that I started with was 7, and the number that I ended with is 7. So in mathematics, squaring a number, raising it to the second power, and then taking the square root will give you what you started with. They're opposites. It will work with cubing a number. It actually will work with raising a number to the fourth power, to the fifth power, and so on. I'll show you one quick sample of a cube. So if I gave you 2 to the third, I would want you to evaluate that or give me an answer for it. 2 times 2 times 2 and that would be 2 times 2 is 4, and 4 times 2 is 8. 2 to the third is 8. Then if I took my answer of 8 and put it underneath a cube root and wrote it like this, whether you use your calculator or not, you need to make sure you know how to use your calculator for cube roots and square roots. But the cube root of 8 is asking you what number times itself 3 times gives you 8 back. And that answer is 2. Again, notice what you had to begin with. What you had to begin with is the same as what you ended up with. Okay, next in your notes, I would like you to write down this information, nth root. I'm using n to stand for any number, the nth root of a problem, because the ones we're going to focus on most likely are just going to be square roots and cube roots, but I do want you to know that there are other roots or radicals as well. The nth root, n, is called the index number. The number or variable or expression underneath the radical, I have b written here, that's called the radicand. The nth root of b, n is index and b is radicand. Up here in this problem, the index number is 2. When you just see the symbol, like the radical symbol written, and there's not a little number here, it is always 2. And the radicand was 49 in this problem. In this problem, the index number is 3, where the radicand is 8. Just making sure you understand the language, the vocab, because I will be using those words often. So what we're going to learn in this unit is how to simplify radicals, using a simplified radical answer, and of course you can use your calculator, but you cannot give me decimal answers. So simplify following radicals without giving me a decimal, and we're going to start with the first 3. Example 1. Notice that example 1 gives you the square root of 36. Now in the last unit we were working on complex numbers, and and air problems had like negative numbers underneath the radical, something like this. Okay, so a little side note for a minute. We were working on problems in the last unit that was the square root of negative 25. What we did is we typed it in our calculator and we knew it did not work. Nothing times itself is negative 25. So what we had to do is factor out a negative 1. We learned in the last unit that the square root of a negative 1, this part, was the I part. And then we looked at the other number, and if it was a perfect square in that perfect squared list, and we knew a number times itself that would give us 25, it would come outside the radical and be simplified. And so square root of 25 gives me 5. So this is very similar to the idea of what we're going to learn in this unit, except our radicands will not be negative in this unit. Last unit they were, so you could understand the definition of I and how it related to imaginary numbers. Okay, so let's take a look at question number 1. Notice that the index number is missing. So remember I said that that's 2. So it's a square root. The radicand is 36. This question is asking you to look at square roots. Okay, so I'm looking at my perfect squared list again. Go back here. And I notice that as I scroll through these perfect squares, that 36 is actually on the list. 6 times 6 is 36. So that means that when I'm asking you to give me the square root of 36, that your answer to that is just 6. Square root again means what number times itself is 36, and you'll just give me that number one time. Okay, and again, these are just very simplified. I'm starting you out with like the easiest questions, but you've got to make sure that you understand the math symbols. Okay, question 2. The index number is 2. The radicand is 144. The square root of 144. What number times itself is 144? So the first thing you do is you look to see, is this number in your perfect squared list? Go back, scroll down. I do not see 144 in the list, but remember, I did tell you that I stopped at 10 squared. I couldn't go on forever, obviously. So what you're going to need to do is, when the number is bigger than 100, you're going to need to use your calculator. You're going to need to find the symbol, square root of symbol on your calculator. You can use your cell phone for that. You can use an app on your cell phone. You can actually use Desmos, which is on Canvas on the dashboard for Algebra 2. There is a link there that you can use the Desmos calculator. But whatever works for you, you have to be able to have access to that and know how to use it. The square root of 144 is what number times itself is that value. If you type it in your calculator, you're going to end up getting 12 back. 12 times 12 is 144. So that's your answer. Question 3. Notice that this radical has, again, a index number of 2, and the radicand is 80. Once again, same idea. I go back, since it's a square root, I'm looking at this list, not this list. I go down, I look for 80. I do not see 80. I see 81. Okay, so I go back over here, and I try to find I can't give a decimal answer. When I type square root of 80 into my calculator, it's going to give me 8.94. I do not want that answer written down. So what you're learning right now is how to write 80 a different way, as factors. You go back to your perfect squared list. You start at the top. 1 goes into everything. Okay, so actually I'll start at 4. And I'll ask myself, since 80 is the number that I'm trying to figure out, an answer for, is 80 divided by 4 going to give me a nice whole number? When I divide 80 by 4, the answer is 20. So I'm actually going to put little check marks beside every perfect square I can find that evenly divides into 80. So this one's going to work. Then I'm going to divide 80 by 9. When I divide 80 by 9, it does not give me a nice whole number, so 9 is not a good choice. Then I go to the next perfect square in the list, 80 divided by 16. When I divide 80 by 16, the answer I get on a calculator is 5. So 5 is a nice whole number, so I'm going to check mark that one. Then I try 25. So you're just going to have to be really quick at how to evaluate these. And just make sure that you have your calculator in hand and that you're doing this as quickly as you can. 80 divided by 25 does not work. 80 divided by 36 is a decimal, so that doesn't work. 80 divided by 49 does not work. Divided by 64 is a no. 81 is bigger than 80, so we don't need to try that. You have 2 choices right now of a perfect square that divides into 80. You always select the highest one. So I'm going to choose 16 instead of 4. Go over to my slide here. Square root of 80, I'm going to write as 16 times blank. And so if you'd forgotten what you got, then type it in again. 80 divided by 16 is 5. Once you write it as a pair of factors, then your goal is to find which one of these, this one's actually the perfect square, this one's going to simplify. What that means, what I like to do is underline the part that simplifies. So now this says the square root of 16. That comes outside the symbol. So I'm going to go ahead and bring that down as a 4. And then 5 is not a perfect square, and so I'm going to have to leave 5 underneath the radical symbol. When I use the word radical, square root, root, they all mean the same thing. So the answer is 4 square root of 5. If you'll type in 4 square root of 5 on your calculator right now at home, and then you'll type in the original problem of square root of 80, you will get the exact same decimal answer showing you that these are equivalent. Again, in this entire unit, when I ask you to simplify radicals, this is our major learning target. We want to do it this way. We do not just type it in the calculator and give a decimal answer. Alright, keep repeating that because I want to make sure you understand. You won't get any credit for just giving me a decimal. Alright, let's practice this idea again. We're moving on to number 4. We notice that this one says, find the square root of 192. The index number is 2. The radicand is 192. Because it's a square root, I go back and I look at my perfect squared list. 192 is not on the list because it's bigger than 100. So I next I should say, type this in my calculator. Square root of 192. When you do that, you get 13.8564 and so on. I do not want the decimal answer. So what I do is I drop down my symbol, radical symbol. I go back to my perfect squares and I try to find the biggest number that goes in to 192. Okay, I'm going to show this one more time, the technique, and then you're going to have to do all of that on the calculator. You're starting with 192, you're dividing it by 4. It actually gives you a whole number, so I'm going to put a little check mark there. Next, you go on to the next perfect square. 192 divided by 9 does not work. 192 divided by 16 does work. 192 divided by 25 does not work. 192 divided by 36 does not work. 192 divided by 49 also does not work. 192 divided by 64 does work. 192 divided by 81 does not work. 192 divided by 100 doesn't work. The next perfect square is 121, and that's getting closer to 192, so it's not going to work. So we have 3 choices right now. Remember, you always choose the highest one. You'll go back, you'll fill in, let's see, 64. You'll fill in 64 times your other factor. So when you divided 192 by 64 a minute ago, you should have gotten 3. So 64 times 3 is 192. Again, when this is not a perfect square, you're just trying to write it as factors, something times a different value that gives you that back. Always underline the part that simplifies. We can do the square root of 64. Something times something 64 is 8. You're going to bring the 8 on the outside. You're going to leave the 3 underneath the radical. 8 square root of 3 is the best simplified answer. Okay, we're going to move to number 5. Number 5, I want you to notice that the index number I have changed on you. It is a 3. The radicand is 64. This is asking for the cube root of 64. In other words, what number times itself 3 times is 64. Because it's a cube root, we go back to our first set of notes and we're looking at the cube list. We're looking to see if 64 is in this list. And right there it is. 4 to the third is 64. So that must mean the cube root of 64 is just a nice whole number. It's just 4. That one is an easy one, like these. Question 6. Again, notice the index number is 3 this time, cube root. And then we have this cube root of 80. We have 80 is the radical. So I go to my cube list. I'll look to see if 80 is on this list, and it is not. So then my game plan is I take 80 and I start using this set of numbers. I'm trying to find the biggest number that divides into 80. Don't start with 1. 1 always works. We'll start with 8. When you divide 80 by 8, it actually works. Okay, let me get rid of my previous check mark. Divide 80 by 27, it does not. Divide 80 by 64, that won't work. Dividing 80 by 125 does not make sense because this is bigger, so it's not going to go into a smaller number. The only perfect cube I can find that divides into 80 is 8. So watch how I write this. I drop my little cube root down. Please make sure you do not forget the little index number, because if you do, it will be wrong. You're going to write this as 8 times 10. 8 times 10 is 80. You're then going to underline the perfect cube, the one that you know you have to simplify. Cube root of 8 is 2, so you'll bring the 2 on the outside. 10 is just going to have to stay where it is. It's going to stay underneath the cube root symbol. So the answer to my question 6 is 2 times the cube root of 10. Make sure, again, before we go on to different types of problems, okay, you make sure you always pay attention to the index number. That way you know if you're supposed to look at the perfect square list or the perfect cube list. You then, secondly, see if this works. Put it in your calculator, do it in your head. If it gives you a nice whole number, go for it, like number 1 and 2 and number 5. If when you type it in, it gives you a decimal, do not give me the decimal answer. Your game plan is to go back, look at your list, find the biggest perfect square or the biggest perfect cube that divides into your problem. When you find it, write that number as a pair of factors. Underline the piece that you know you can simplify so it comes outside the radical, and leave the other number underneath. Alright, next, we're going to do the ones on the screen right now that are highlighted only. This question is cube root of negative 27. Index is 3, radican's negative 27. We're dealing with a cube root though, and not a square root. Cube root means what number times itself 3 times gives you negative 27. So I don't want you to be confused as to comparing this to the complex number unit, because we were doing imaginary numbers. 2 negatives don't make a negative, but 3 negatives do. So when you type this in your calculator, you should get back negative 3 as the answer. Negative 3 times negative 3 times another negative 3 is going to give you back negative 27. Again, if this had been a square root, then the answer would have been imaginary. But since it's a cube root, your brain has to think differently, and you do have to switch gears and go back and think about perfect cubes. Notice that 27's in there. Now mine's negative, of course, so that's why the answer's negative. You're going to have to make sure that you are separating in your head what square root means, what cube root means, because it's easy to get confused. You're going to have to be careful. On number 2, on this slide, I have an index of 2. I have a radicand of 32x to the 10th y to the 15th. My first thought is, okay, I've got a square root. Let me look at my perfect squared list and see if 32 is in it. 32 is not there. So what do? I now write this as the square root of different factors of 32. So I got to go back and I got to find the biggest perfect square that goes into 32. Alright, let me erase my previous check marks. Again, what I'm showing you is how you have to do on your own. It's the same game plan. You start with 32 was your number, and you divide it by 4. 32 divided by 4 is 8. It actually works. I'm going to put a little check mark. Then you divide 32 by 9. If I make that a 9, does it work? No, it gives me a decimal. 32 divided by 16. Actually, it's 2. It does work. 32 divided by 25 is a decimal. No. 32 divided by 36 does not make sense. 36 is bigger than 32. So between these two options, I choose 16. 16 is bigger than 4. I go over here, I write this as 16 times blank. 16 times 2 is 32. Alright, now on this part, 16 is the perfect square. So I know that the square root of 16 is the part that comes outside. So I would, let me come up here, if the square root of 16 is 4, I'm going to write it in front of the radical, and then I'm going to put the 2 and leave it underneath the radical. Now what's different about my question 2 from all the other ones we've done today is that it has a variable. So what you do in this case is you take the variable, the power, and you divide the power by the index. Power divided by the index. So let me backtrack for a second and erase this. You're going to underline everything that simplifies. So 16 simplifies. Let me copy this back down. X to the 10th simplifies. And then I have y to the 15th. But when I divide 15 by 2, it's not a nice whole number. So what I have to do is write it as y to the 14th. Y to the 14th, because 14 is an even number. So 14 and 1. 14 and 1. So then I'm going to write this as y to the 14th and y to the 1st. You again are underlining all the parts that simplify. So you're going to underline 16. You're going to underline x to the 10th. You're going to underline y to the 14th. Alright, those parts simplify. So you're going to pull that out. And your answer should be a 4. And then the square root of x to the 10th is going to be x to the 10 divided by 2, which is 5. Y to the 14th, 14 divided by 2 is 7. Y to the 7th will be part of your answer. Notice all the pieces I've underlined. And the parts I have not underlined stay underneath the radical. So the 2 is going to stay where it is, and also the y. Okay, so in your notes, you need to write down divide power by index.